So today's topic is going to be least common multiple of compound algebraic expressions. First, we need to know what it's a compound algebraic expression. A compound algebraic expression refers to those expressions that can be factorized more than one time. So the idea in this case is that we will need to factorize more than one time to obtain the least common multiple. So let's see. The steps are: first, we will factorize each polynomial to the minimum. As I was telling you, normally we will do it twice. First, we will take out the greatest common factor, and maybe then we will use another case of factoring. The idea after that is when we have the factors of each polynomial, we will find the least common multiple of the monomial part, because those factors will have parentheses and something outside the parentheses. So that means we will find first the monomial part least common factor, those terms that are outside the parentheses. Then we will find the least common multiple of the factors, those that are between parentheses. And after that, after finding these two, we will write the compound least common multiples. So let's see some examples. So the first exercise is this one. We have two different polynomials. The first one, we need to take out a greatest common factor. In this case, both of them are divisible by 6 and the highest power common is x. So if I open up a parenthesis, 6x to become x cubed, it's going to be x squared. 6 to become minus 54 needs to be multiplied by minus 9, and that's it. The other one is going to be, I can take out the 4x squared because all of them are divisible by 4 and the highest common power is x squared. So it's going to be x squared minus 6x plus 9. So now we can continue factorizing because this one, it's a difference of squares. And we can factorize also this one because it's a perfect square trinomial. So if I factorize those, I will get 6x that multiplies x plus 3, x minus 3. Remember, a difference of squares, it's decomposed in the root of the one that it's positive, positive in both parentheses, the root of the negative, positive on the first one, negative on the second one. In the other one will be a perfect square trinomial. Remember, it's going to be the square root of the first one, the sine of the second one, the square root of the third one, all of it squared. So in this case, I need to look for the least common multiple between the monomial part, between the 6x and the 4x squared. Well, we can decompose the 4 and the 6 to obtain between those the least common multiple. So it's going to be using the prime decomposition, or maybe you can do it by mind also because it's very simple. And it's going to be 12. So our compound least common multiple will be 12. Between x and x squared, remember we need to write the highest power, x squared. Between the factors, I have x plus 3 and x minus 3. And remember, I need to write the highest one. Of x plus 3, it's to the 1. But for x minus 3, here I have it to the 1, but here I have it to the second power. So x minus 3 needs to be to the second power. And this is going to be our actual least common multiple between those specific polynomials. So the idea is basically the same as I was telling you. We do the factoring of every polynomial. In this case, we need to make it twice normally. After doing that, we need to look for the least common multiple of the monomial part. In this case, between 6x and 4x, it's 4x squared, I'm sorry. It's Between the numbers 6 and 4, the least common multiple is 12. Between x and x squared, the least common multiple is x squared. Then we will go with the factors. The parentheses part, we have x plus 3 and x minus 3. X plus 3, the highest one is to the 1. X minus 3, the highest one is to the second power. So that's why this one, 12x squared, that multiplies x plus 3 times x minus 3 squared, is our least common multiple of these compound algebraic expressions. So let's see another example. So in this case, we have three different parts. One of it's a polynomial. I mean, two of them are polynomials. One of them is a monomial, but don't worry about it. We can do it. It's the same part. We need to factorize each term or each expression we have to the minimum, and then we will see the process to finding out the least common multiple between the monomial and between the factors. So let's see. On the first polynomial, I can take out a 3a, and it's going to be a minus 2. The second one, it's a monomial, so I cannot do anything. It will stay the same. But for the third one, I can take out a 5, and it's going to be a squared minus 4. In this case, this part, it's a difference of squares. So we can continue factorizing that part. So it's going to be 5 that multiplies a plus 2 that multiplies a minus 2. So let's see. After that, we need to look for the least common multiple between the monomial part, those that are not in parentheses. So between the numbers, we have 3, 6, and 5. So we can do the prime decomposition, and it's going to be 5 times 2 times 3, that it's 30. So the number is going to be 30. What about the a? We have a here, a cubed, and no letter here. Remember, we need to put that the one that is the highest value. So in this case, it's going to be a cubed. Then we will write the factors. In this case, we have a minus 2, a plus 2. So we will write the factors, a plus 2 and a minus 2 with the highest power. In this case, the highest power is 1 because a minus 2 is here to the 1, but here is also to the 1. A plus 2 is here only to the 1. So this is our least common multiple of those compound expressions. So the idea is very simple. It's only factorizing our expressions to the minimum, then find the least common multiple of the monomial part, then find the least common multiple of the factors of the parentheses, and after that we will write the compound least common multiple. So we will do one last exercise number 3. It's very similar. Remember, first we need to factorize each polynomial to the minimum. Then we will find the least common multiple of the monomial part. Then we will find the least common multiple of the parentheses, the factors, and then we will write the compound least common multiple. So for the first one, I can take out as a common factor a 5x cubed, and it's going to be x squared minus 80 over 5, it's 16. Then we will have 5 that multiplies x squared that multiplies 2x minus 8. And finally, we will have this one that it's a perfect square trinomial, and it's going to be x minus 2, all of it squared. So let's see. This one we can continue factorizing because it's a difference of squares. So what we need to do here, it's going to be 5x cubed that multiplies x plus 4 that multiplies x minus 4. This one, it's a trinomial of the form x squared plus bx plus c. So we can factorize it also, and it's going to be x plus x minus, two numbers that when they get added we get 2, when multiplied we get 8. It's going to be plus 4 and minus 2. So now we can, or we have oral terms factorized to the minimum. So let's see. For the monomial part we have 5, 5, and here we have a 1. So it's going to be a 5. What about the letters? We have in the monomial part x cubed, no letter, no letter. So the minimum will be 5x cubed. Then we need to write the factors. We have x plus 4, x minus 4, and also x minus 2. Remember, we need to write it the highest power of each one. X plus 4 it's positive here to the 1 here. X minus 4 is to the 1, but x minus 2 here is to the 1, here is to the second power. So it's going to be x minus 2 to the second power. And this is going to be our actual answer for the least common multiple of those compound algebraic expressions. So that will be it for today's topic. So you can do the activity that it's least common multiple of compound algebraic fractions. See you next time.